Right, so when we're talking about movement in the body, there's different terms that we talk about with specific muscles. Okay? For a certain motion, there's going to be one or two muscles that are going to be the prime movers. Okay? So a prime mover is the major muscle that contributes to that motion. Okay? So if you talk about shoulder flexion, elbow flexion, different things like that, extension. Like for example, major prime mover of elbow extension is going to be the triceps. When we go through different parts of the body, we'll say, okay, this is one muscle, the prime mover for that particular activity. And then you can have synergists. And those are muscles that work together to help the prime mover. And then also if you have a synergist, then you have an antagonist. So we're talking about extension. The triceps is the prime mover for extension. And then you can have antagonists are muscles that do the opposite motion, like the brachialis and the biceps. And then you'll have other terms we'll refer to stabilizers or fixators. So if we're going to be doing movement at the shoulder joint or glenohumeral joint, we need to stabilize the scapula. So there's fixators would be muscles that help to stabilize the scapula. Serratus anterior, triceps, things like that. So when we're talking specifically about fixators, those are muscles that fix a joint to a given position so that other joints can move. So if you're talking about the scapulothoracic joint, which is the joint between the actual scapula and the rib cage, the scapula is going to get held to the rib cage so then the humerus can move around. So some muscles are going to stabilize or fixate a joint, one part of the joint, another part of the joint can move around. And then again, and there's a little more detailed information about antagonists, and there's some other material in there in the notes that you can read over. Then you talk about the muscle belly. Okay, that's going to be like the main part of the middle of the muscle. Right? You may have a tendon on either end. The muscle is like the middle part, or the bulkier part of the muscle. Now, in muscles, they either contract all the way or they don't contract at all. It's not like part of the muscle fibers are going to contract, they're all going to move. So that's what's called the all or none principle. And then when we talk about muscle contractions, the main ones that we'll talk about is isotonic contraction and isometric. So isometric, iso meaning same, right? So metric meaning measure of movement. So isometric is like this, where you contract a muscle and not move in the joint. Right? And then isotonic is where you're changing the muscle length as it contracts, and the tone is staying more the same. And you can actually have two different types of isotonic contractions, and those are going to be, so there's concentric contractions and eccentric. Concentric is an isotonic muscle contraction where the muscle is shortening as it contracts, like this. So if I'm doing a curl like this, the biceps is shortening as it contracts. And then if I'm lowering the weight down, my biceps is still contracting, but it's lengthening as it contracts. So this is a concentric contraction, this is an eccentric contraction. Right? If you didn't have an eccentric contraction, then things would just drop back down, right? So eccentric contractions are where you're slowly controlling the motion of letting your arm come down. Or for example, when you're walking, your foot doesn't just flop down like that. Although sometimes people have a neurological problem, they'll have a foot drop, so they have to raise their foot up like that. But when you're walking, your foot gets gradually lowered down. So those are eccentric muscle contractions. So instead of just flopping down, it's a controlled elongation of the muscle. So here's isotonic. So if the muscle is shortening like that, what kind of contraction is that? Concentric. And then if it's lengthening, it's what kind? Eccentric. Right. So then, like I mentioned before, iso is meaning same, and metric is in terms of measure or length. So in this case, the muscle length is not changing. So that's something where, like if you're having a stabilizer or a fixator muscle, or like you're doing like this, you're contracting the muscle, but it's not changing in length, not moving the joint. Something that's going to happen, like something you go to try to lift something and it's heavier than what you can lift. Now you can lift something. Okay, you're not moving, right? Unless you can overpower the weight of that object, then you're going to push it off of you like that person was falling down the cliff.
Can I ask a question?
Sure.
So, on what you just said and before, the all or nothing principle, it said that all the fibers contract together every time the muscle is used, is that right?
Yeah.
So in the video, they don't.
Yeah, it's kind of a discrepancy. You're saying that all or in principle is that all the muscles, all the fibers are going to contract. But in the video, they're saying that most people don't use all of their muscles.
Right.
So, that is a discrepancy.
So has there been?
I think what they're talking about is that in each individual fiber, the whole thing is going to contract. I'll have to do some research on that and maybe try to come up with a better answer. I don't know that right now, so I'll make sure to figure that out, what you mean by that. But I know that, like, when you have action potential, once you get enough stimulus to activate the potential, it's a full-blown action potential. It doesn't correspond to more stimulation, means more of an action potential and less. It's like it doesn't have volume. You can't turn it up or down. It's either on or off. I think the all or none principle has to do with either the muscles contracted or it's not contracted. And then maybe there's sometimes all the fibers are contracting or not, but I'll get a better answer for that later.
Correct me if I'm wrong, I always took the all or nothing principle to indicate when a nerve innervates a particular muscle, like every fiber that's connected to contracts at the same time, meaning like you can't just contract part of the muscle when one nerve innervates at all. Is that
Yeah,
correct?
that's kind of, I would understand it, but that's a little bit different than what they're saying in the video. I'm not sure what they mean exactly by that.
Okay.
But maybe we'll have to talk to the Discovery Channel about that. So here, then, isometric is the muscle contracts, but it doesn't change in length. Okay, so these are different characteristics of muscle tissue. And it's the fact that it's excitable. I think this is a little bit out of order. I saw it somewhere in the notes. On what page is that?
Page 39.
Okay. So basically the muscle is excitable, which means it can respond. It's similar to nerve tissue. Nerve tissue and muscle tissue are things that can respond to stimulation. But specifically in muscle, the idea is that it's tractable. So that's a specific property of muscle, is the fact that it contracts. And then also to go along with that, it can contract, but it also stretch. So muscle is the main thing that provides movement in the body, so obviously you're going to have to be able to shorten and lengthen. And then elasticity is that the fact that it can go back to its original state. If it's shortened or lengthened, it can go back to its original state. So it has an elastic property.